Now that we've seen what the graphs of these rational functions look like, let's talk about how we can analyze them without necessarily having to graph them, or before we graph them. So when we have a rational function, remember, a rational function means that it's a fraction. So in general, we can think of it as a numerator over a denominator, where usually the numerator and denominator are going to be polynomials, but they could be, in theory, they could be any kind of function. Okay, now rational functions, that's a huge topic. There's a lot of different types of rational functions, lots of different features that are interesting that we want to study. But for our purposes here, we're going to start by looking at a fairly simple model. So we're going to look at a simple template for a basic rational function. That's going to look like this. So here's the template that we're going to start with. Our function, f of x, is going to be a over x minus h plus k. A over x minus h plus k. So this will be the starting point that we start to investigate some of the features of rational functions with. Now, when we talk about rational functions, there's several different properties that we want to be able to identify. Okay, and these are the three main properties that we're going to start to learn how to identify about a rational function. So one is its vertical asymptote. So remember, in a rational function, you often have these vertical lines, like here. This is the graph that I showed you before, that divide the graph into different sections. And these lines are lines that are like boundaries. So your graph can't cross those lines. It'll often get closer and closer, but never actually touch or cross those lines. So those lines that kind of divide up the graph vertically into different sections are called the vertical asymptotes. So we want to find where those are. We also want to know how to find the horizontal asymptote. So like on this graph, this line here going from left to right, this purple dashed line, this is a horizontal asymptote because it divides the graph in two sections vertically. So as the graph goes either further to the right or to the left, the graph kind of levels off and kind of approaches, gets closer and closer to that asymptote line, but never actually will cross it or touch it. So again, it's like a boundary line dividing the graph in sections vertically. And so we want to know where those lines are. And then finally, we want to be able to graph it. So we won't always necessarily have a nice graphing tool like Desmos or a graphing calculator that'll graph it for us. We want to be able to graph it ourselves if we need to by hand. Okay, so these are the three features. And these first two features are going to help us get the graph. So once we know how to identify the vertical and horizontal asymptotes, then that's going to really help us draw the graph, because then it'll divide it in sections and then we can just fill in each section. Okay, so let's talk about how we can get that for our simple template that we have here. Okay, now let's start with the vertical asymptotes. So the vertical asymptotes, these lines that divide the graph in horizontal sections, those are going to occur wherever we have our denominator of our fraction equal to 0. Because remember, when you're talking about dividing numbers, you cannot divide by 0. You cannot have 0 in the bottom denominator of a fraction. That's not allowed. That's undefined. 0 in the top dividing into 0 is okay. 0 in the top of a fraction, that's just 0. But 0 on the bottom denominator of a fraction, that's undefined. So that's going to be a problem. So we're going to get these vertical asymptotes, these lines that divide the graph in sections. We're going to get those wherever we have a fraction with a 0 in the bottom, 0 in the denominator. So when we look at our template, this first part is the only fraction. The denominator bottom is going to be 0 when x minus h is 0. Okay, when is x minus h equal to 0? Well, when x is equal to h. So when x is equal to h, this fraction will have a 0 denominator, which means it's undefined, and that's where we're going to have these vertical asymptotes. So for this model template function that I have here, the vertical asymptotes are going to appear where x is equal to h. X equals h. And notice that's the equation for a line. Remember when we studied lines, linear functions, we learned about how a vertical line has an equation x equals something. And so in this case, x equals h, that represents a vertical line, okay, like these lines in this graph here. And those are going to be the vertical asymptotes. So what happens there is it divides the graph in sections horizontally. And as the graph approaches those lines, it'll get closer and closer. It'll either zoom up or zoom down. It'll get closer and closer to that line, but never touch it or cross it. So those are our vertical asymptotes. Okay, now what about the other ones, the horizontal asymptotes? Okay, these horizontal lines that divide the graph in sections, vertical sections. Okay, so these lines are going to happen. You can find out where those lines are by thinking about what happens as you go further to the right or further to the left. Okay, as you go further to the right or left, as x gets bigger, in other words, think about what happens as x gets really, really big. So as x gets really, really big, what happens to the value of this function? Okay, so let's look at this function that we have here, our template, a over x minus h plus k. So x appears in the bottom, the denominator of this fraction here. So think about what happens for large values of x. So as x gets really big, this bottom of this fraction, this denominator, is going to get really big. Okay, you're subtracting h from it, but at some point, x is going to be so big that subtracting a number from it, it's not going to make a difference. It's still going to be a big number. So as x gets really big, the denominator, bottom of this fraction, gets really big. Now think about fractions. When you have a fraction where the denominator is big, the overall size of the fraction is small. Okay, like 1 over 1 million is actually a really small decimal. 1 over 1 billion is even smaller. 1 over 1 trillion is even smaller than that. So in a fraction, as a denominator, bottom gets bigger, the overall fraction gets really small. So as x gets really big, and the bottom of this fraction gets really big, the overall fraction, this first term of this template that we have here, is going to really get small. And as x gets bigger and bigger, eventually it gets so small that we can kind of ignore it. It gets so small we can just ignore it. It just becomes insignificant. And so for large values of x, what happens is the value of this function looks more and more like k, this number, this constant on the end. And so as x gets large, the value of the function looks more and more like k, so it kind of will plateau out and get closer and closer to the value k. And so that's how we find what our horizontal asymptote is. So our horizontal asymptotes, these horizontal lines that divide the graph in sections, vertical, top and a bottom section, those are going to occur when y equals h. Okay, so as the function value, which is your y value, as x gets larger and larger, the function value, the y value, gets closer and closer to h, because this fraction gets smaller and smaller since the denominator gets bigger and bigger. Okay, so for large values of x, this function looks more and more like h. The y values of this function look more and more closer to h, or k, excuse me, look more and more closer to k. So y equals k is going to be where our horizontal asymptote is. Okay, so for our template model simple rational function, the vertical asymptote is going to be at x equals h, and the horizontal asymptote is going to be at y equals k. Okay, now once we know where those are, then I'm going to show you in the next segment how easy it's going to be for us to actually graph those. Okay, so we're going to start by looking at this model template here.